Hi everyone and welcome back again. So last video I have talked about how to calculate the summation of two matrices by using Java programming. So in this video I'm gonna talk about how to calculate the some diagonal elements of a matrix and how to calculate the upper triangle and lower triangle elements of matrix. So this is a matrix, the 4 by 4 matrix. So to get the diagonal and upper triangle, lower triangle, of course we always need to we have to must should have a square matrix. That means where row and column is same. So here the diagonal matrix means where the row and column, for example, diagonal means row and column elements will be same. Like it. This is for diagonal. Diagonal elements is row and column will be same for diagonal. And upper triangle, upper triangle will be row always will be less than column. I mean, upper triangle always will be the row column. It's column. This is for upper triangle. Column will be always greater than for upper triangle. And the last one, lower triangle. In lower triangle, row always will be greater than column number compare. So here is therefore diagonal elements sum 34 and upper 51 and lower 51. That is the diagonal, that is upper triangle, that is lower triangle. So now I'm going to show you how to calculate it by using Java programming. So let's check it out on NetBeans. So here I already opened a new class that is sum of elements. And then at first my duty is to create here a main method. Then uh, though I'm going to uh, calculate here sum of diagonal elements, sum of upper triangle elements and sum of lower triangle elements. So I can declare some variables here. Integer sum of elements. I say integer triangle elements, upper triangle, integer sum of upper triangle elements. Sorry. And then last one is integer and see sum of lower triangle elements. These three. Now I need to create a scanner class for input. Send.in. Here, so inside input, I need to create a arrays. This array will be, let me import it first. This array will be the integer to the array. I can just, our matrix name will be matrix A. Matrix A is equal to new integer. So I can just write here, column will be 4 and then row will be 4. Row will be 4 and column will be 4 here. And then to get user input, I can use a for loop. First for loop is for row, as I also show in last video, and it will be start from 0 and it will be end before 4 means until 3. And then this one for column. For this one is a column. Column, and column will be start from 0 and until 4. Column will be end until 4 here. So after that, I can just create a space how I can put my input like print. And then I can say it will be printf because I want to see the in same line like I already show you how to use %d like a, then column, inside column, %d, %d, and again inside row also %d. It will show me there, and then I have to use here printf function. This is the printf. Then I can say matrix A, mm, row, and then column is equal to input dot next integer, input dot next integer. That's all until my getting user input. So after get user input, let me just double. After getting user input, now it's time for me to print this matrix. So to print this matrix, I can just create a something like for matrix A heading tri x matrix A heading print on. Then printing matrix will be also like same this looping system, like because it's the same matrix I've been, so I can just copy it, and after that I can print here matrix A and print it. And I want to put the between two elements of a row, I want to create a space. It means shift tab, and then I can just print here matrix A. Just I can put matrix A. Sorry, matrix A. I print here. So I need to read another bracket for this. This until for matrix A. So here it will print the first row. Then after first row, before second row, I need to print a new line. So it's a new line, then second row, then again loop will come here, and again loop will work here, and then third row, then again print a new line, then the last line. So until here. Now it's time for me to calculate the diagonal, and so for diagonal and for triangle, lower triangle, I can copy the same because it is the same matrix. I can use same loop. It will be print, but I can create some condition here. So first condition is here. I say if, as I already show, row is equal to column. That time will be for diagonal. What will be seen? We already created a variable sum of diagonal. Okay. Initially, we think this sum of diagonal elements is equal to 0. We can talk about also this one equal to 0. Initially, it's 0 because we are going to plus 1 by 1 by 1. So first is 0. We start from 0. So I can just say sum of diagonal elements here. Sum of diagonal elements is equal to sum of diagonal elements plus matrix A, row and column. Which kind of column? Row and column. So I can just copy it here. Why I copy here? Because it will save my time. So diagonal, sum of diagonal elements, this row and column will be whenever the both index will be same. Only it will work for that. This is for diagonal. And now I can say if the column greater than row, that time it will be upper triangle elements. So I can just copy it here, upper triangle elements. And see, upper triangle elements is equal to upper triangle elements plus matrix A, row and column. This row and column will be working for that. Oh, working for that. After that, at the last, for example, I can just the last one, if row greater than column, I just say like column row, I can write it, yeah. Then I can see it will be the lower, if row is greater than column, it will be the lower triangle, sum of lower elements of lower triangle, some lower triangle elements. So some lower triangle of elements is equal to plus matrix A, row and column. So what will be working? This row and column will work only for whenever row index is greater than column index. Just for until now here. Now I can print it. So like sum of diagonal elements. Then I can just print that sum of diagonal elements. Then print it. Copy. And I can just copy it. Control Shift plus down arrow. So as the sum of upper triangle elements, and it will be sum of upper triangle elements. And then the last one is lower triangle elements. Triangle elements. So it will be the lower triangle elements. Sum of lower triangle elements. Sum of lower triangle elements. Let me just create some space here. Okay, so that's all until this code. So let me run it first. Run. Message operation. Okay, %d. I did a mistake. So %d. Okay, so sorry. I need to also tell here the row and column because I just forgot it. The format specifier. So after that, until then, so %d, I can put here a equal. Then equal, I can write here row. It will work for and column. Use here print because of it. I forgot it to do it. Okay, so again done. Sorry. New line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, now it's all working. So A is the matrix elements and the diagonal elements, that means 1, 6, 11, 12 is 34, and the upper 2, 3, 7, 4, 8 is equal to 36, and the lower 9, 10, 15, and 14, 13 is equal to 66. So that was all for diagonal element sum and upper triangle element sum and lower triangle element sum until now. So that's all. Thank you.